Now, this question states that we need to express this expression in this form. So what we need to do is we need to find the value of r, and we need to find the value of this phi. Okay, to find the value of r, it's fairly simple. It's the magnitude or the radius of this entire expression. And you just find that out by finding the square of whatever is being multiplied with the sine term and the square of whatever is being multiplied with the cos term, in this case 12 and 15 respectively. Add the squares up and take the under root. In this particular case, it ends up being 13. We found the value of r. But now we need to find the value of this phi. Okay, how do we do that? Standard procedure is that basically you can write this down like this, right? We found out the value of r as 13, and now basically you need to, since 13 is being multiplied with sine theta, with 12 sine theta, you also have to divide 12 sine theta by 13, and same goes for 5 cos theta. Since 13 is being multiplied with 5 cos theta, you need to divide it by 13 as well, so that the actual value of the function does not change. Okay, fairly simple so far. Now look at this. You need to express this in this form, right? R sine theta plus phi. So do substitutions. How? Well, basically you can replace this 12 by 13 with cos phi. You can replace this phi by 13 with sine phi. You're assuming that cos phi is equal to 12 by 13 and sine phi is equal to phi by 13. Now why do we do that? Well, because the first thing we need to do is express this entire thing like this. And why do we need to do that? Now, do you remember the sine identity? Looks familiar, right? Because sine alpha plus beta is equal to sine alpha cos beta plus sine beta cos alpha. And if you treat alpha as theta and beta as phi, well, you can now write this entire thing as sine theta plus phi. So now you have it in this form, except you do not know the value of phi yet, right? So how do we do that? Well, you know that cos phi is equal to 12 by 13. You know that sine phi is equal to phi by 13. What's tan phi? It's just sine phi divided by cos phi. And that just ends up being, well, let's just do it by hand. Sine phi over cos phi. That means 12 by not 12 by 13, sorry, 5 by 13 divided by 12 by 13, and that ends up being 5 by 12, not 13, it's 12. So now phi is equal to tan inverse of 5 by 12. And once you find out this value of phi, just replace it into this phi over here, right? And then you have the true value of the function in the form r sine of theta plus phi.